Hi everyone, soil mechanics. This time we want to continue our last problem, but this time the retaining wall, but against the factor of safety against overturning this time. So again, if we have a concrete retaining wall in a saturated soil and uh, that there is a harness rod which help the concrete structure. So we want to see if we have a long concrete retaining wall stand against a mass of saturated soil and harness rod are helping the concrete retaining wall, and if we do know the tensile, this time we do know the tensile force in each rod is 33 tons. We want to know what is the distance between each two the harness rod is. If we have the factor of safety against overturning, this time is equal to 1, and also ignoring the friction and cohesion of rod and concrete wall. So rod and concrete, there is a friction between harness rod and concrete wall. We are ignoring them, and just the tangent of delta is equal to 0.4. The factor of safety against overturning in our problem is provided to be 1, and factor of safety against overturning is resisting moment this time over the destructive moment. And again, if we do know the tensile force in each rod is 33 tons, we want to know what the distance is. To do so, if we just draw the retaining wall and the forces applied on that, so this is the effective pressure force, tensile force, and also there is a weight of concrete in a vertical direction. And if we have a moment based off point O, definitely the friction forces remove because it just passes through the point O, and weight of concrete through the distance, which is the half of a 1 meter, and tensile force times 4 meter. This is 4 because this is again last problem. This is 2 meters. And FA, we already calculate FA. We just multiply it by 1/3 of this base of this triangle, and it just gives us 2 meters height of this triangle, and that's 2 meters times FA. It just gives us a 24 S because FA is a half of KA, which is replaced from here, scum of soil, which is 2, and times a height of retaining wall, which is 2 meters plus 4 meters, 6 squared times S, which is distance of rod, which is our width, and MA is equal to 24S. Weight of concrete is unit weight of concrete times volume. That's 2.5, which is provided in problem statement, times 6 times 1 times AS, which is the width, gives us the volume of concrete. And we do know the tensile force is 33 tons. This is 15S, this is 24S. And if we just move to our equation for factor of safety against overturning, is resisting moment over destructive moment. Factor of safety is provided to be 1. In the real case, this is like 1.723, something like that. This is very a small amount for factor of safety just in case, but in our problem, it just provided to be 1. So it just gives us a 24S is equal to 7.24 is a destructive moment is equal to 7.5 times S plus 33 times 4, which is the tensile force times the arm, which is 4 meters already provided in problem statement. So if that's the case, it just gives us a, let me make it a bit cleaner. It just gives us like WC plus times zero point 0.5, which is this force times the distance, vertical distance through point O plus T, tensile force times a arm, which is 4 meters, over FA times 2. And if you do so, it just gives you this equation, and that's 15s. This is Fa, and it just gives you S is equal to 8 meters. So again, if you have a factor of safety this time against overturning and you're provided with a tensile force in rod like 33 tons in our problem, the distance of each of them should be 8 meters apart. Thank you. We'll solve more problem in retaining structures.